Alright, today's lesson is finally the last lesson in chapter 1. Okay, so it is 1.10, rational versus irrational numbers. Not hashtags, numbers. So 1.10, rational versus irrational numbers. We started with a story about a month or two ago at this point. That when you first started out in school, or even before school, you first started out at the age of 2 and counting. What number did you start with when you were counting? Crystal?
1.
Exactly. So you started out just by counting with 1, 2, 3, 4, and so on. Does anybody remember what those numbers were called? Ryan?
Natural numbers.
Very good. So we started out our life with natural numbers. Natural numbers are important. Then you said, wow, there's got to be something before 1. And somebody told you, there sure is. And what was that number that they added right before 1? Melody? 0. And that gave us a whole nother group of numbers. So it was all the natural numbers, plus we added the 0. Does anybody remember what those numbers were called? Wyatt? Even before integers, because all this has is 0, 1, 2, and 3. Adam? It's natural numbers plus a 0, which makes it whole numbers. Okay, so we just made our numbers that we know in life, our group of numbers, just a little bit bigger. So for instance, like in first grade, every math problem you did, the answer was a whole number. It was either 0, 1, 2, or 3. And I know that for a fact, because my son's in first grade right now. And all of his addition and subtraction problems, the answers are always whole numbers. But then you start to get a little curious, and you say, everything can't be positive in the world. So then we add another group of numbers. Which group of numbers is just a little bit bigger than whole numbers? Iris? Integers, good. And what are integers? What are integers, Wyatt?
The negative numbers.
Negative and positive, right? So -4, -3, -2, -1, 0, and 1, 2, all the natural numbers, okay? So now we have dots continuing in both directions. So integers are all the positive and all the negative numbers. So negative and positive. So in school, I think a little disservice we do to you is we don't introduce negative numbers right away. And we probably should, because then maybe you would really be good at your integer rules if we introduce them right away. So negative and positive numbers, that's part of the integer family. And then we just took 9 sections of our book talking about another group of numbers. So it has all the natural numbers in it, all the whole numbers in it, all the integers in it, and we called them what kind of numbers? What kind of numbers did we call them? Some. Very good. So our next group, so this is going to get pretty big, this group, are rational numbers. And I say this group is going to get bigger because what's going to be added into rational numbers? Trinity.
Fractions.
Good. Fractions are added in. What else? Decimals. Decimals, good. Percents, very good. More specifically, before I write all those examples, what did we say the definition of a rational number is? Rational numbers, Melody? Perfect. So we're going to write rational numbers. Any, and I'm just going to use the number symbol, any number that can be written as a fraction. And I think we still have, well, we have our graffiti, but where the word rational, it was A over B to make you think that it's when it can be written as a fraction. Examples you gave me were percents, decimals. There's 2 types of decimals we learned about. 2 types of decimals. Kayla? Very good. So terminating and repeating. So an example of terminating might be like 0.25, which is equal to 1/4. An example of repeating might be 0.3 repeating, which is 3/9, or 1/3. So we said percents, decimals, fractions. What also falls under fractions? What are those other things? Like 1/2. What is that called? 1/2. Melody? Mixed numbers. Good. Fractions, mixed numbers. And in the last two chapters, the last two sections, like 1.8, and even yesterday, well, not yesterday, how about 1.8? We talked about what? What kind of numbers did we talk about? Right. We did talk about exponents. Yep, that wasn't in 1.8. Iris? Yes, so square roots, so perfect squares. So perfect squares and perfect cubes, they all fall into rational numbers. But the key word is perfect. Perfect squares and perfect cubes, like the square root of 25 or the cube root of 27. Okay, those are perfect because they have actually a whole number as their answer. These all belong to a big family, which I'm going to write down here, but I still need a little bit of space here. The big family they're part of are called real numbers. Real numbers. So everything you've learned in school, all the numbers you've learned about, are all called real numbers. You've worked with real numbers a lot. The numbers we're going to talk about today, you haven't worked with much. They're called irrational numbers. And that's going to be my box over here. It is not part of rational numbers, so it has to be over there, but it is part of real numbers. So, show you how this flowchart works. We have natural numbers, which are inside whole numbers. Whole numbers are part of the integers. Integers are part of rational numbers, and all rational numbers are real. This is like one big family, and then over here you have a real small family. This is the irrational family, or the irrational numbers. So, irrational numbers. We've talked about them. They're not new. You've seen irrational numbers before. Like this number right here, or that symbol. Does anybody know what that symbol stands for, Crystal? Pi. Very good. The value of pi does not terminate. It does not repeat. It goes on forever and ever and ever. So irrational numbers are decimals that do not repeat or end. They do not repeat or end. Pi is an example of that. Yesterday we talked about a lot of examples that are irrational. Can someone give me an example from yesterday of a number we learned about that's irrational? Melody. Perfect. So the square root of 40 is irrational because it is not a perfect square. It will be 6 point something. And that decimal is not going to end and it's not going to repeat. So that's an example of an irrational number. We can also have irrational cube roots, such as the cube root of 4. Okay, because the cube root of 4 is going to be like 1 point something that keeps repeating and doesn't end. And that is our big family of numbers. So pretty much any number that can be written as a decimal, percent, or fraction, anything like that, most numbers that you've worked with, they're called rational numbers. We're only adding in a few new numbers that are irrational. Anything involving pi, and any non-perfect square or non-perfect cube root.